So a few things about dilations you have to keep in mind. There's always what's called a center of dilation that we dilate from. And a lot of times for us, that's going to be the origin. Like anytime we did our rotations, we had a center of rotation, which was the origin. We will dilate from other points, and we'll see how to do that. It doesn't change things much. But dilating from the origin, we have some special things we can do there, and we'll see that today. So keep in mind, you have a center of dilation, so if I'm referring to that, it's just what point are we dilating from? All right, we also have what's called a scale factor. Okay, and well, I guess before we worry about that, let's just fill in this first blank. In math, the word dilate means to enlarge or reduce a figure. All right, make bigger, make smaller. All right, so the scale factor is going to tell us we're not just making it randomly bigger or smaller. We want to make it bigger and smaller by a certain amount. And the scale factor tells us how big or small we want to make it. If the scale factor is less than 1, and maybe I should change this. If the scale factor is, because we're going to only be dealing with positive scale factors for today, but we will see negative scale factors. And so we have to approach that a little differently. But if the scale factor is, I'm just going to add this. If the absolute value of the scale factor, so I'll just add, this is absolute value. Remember, absolute value just gets rid of your negatives. If the absolute value of the scale factor is less than 1, then your figure gets smaller. If the absolute value of your scale factor is greater than 1, then your figure gets bigger. So it works kind of how you'd expect. If you have a scale factor of 5, you're going to have a bigger figure by 5. If it's negative 5, it'll also be bigger, just in a negative direction. And we're not going to do that today, but we will. So anyways, it's those like 1/8, even like a 6/7. We won't have any scale factor like that. But if we did, a 6/7 scale factor would be smaller than the original, because 6/7 is less than 1. Okay, so now let's look at the actual process of this. And would it be easier to see if we turn the lights off? Yeah. All right, can someone turn the lights off? Okay. So we have, maybe for this first one right here, let's just go through the process of dilating just on the graph. Let's pretend we're not worried about the coordinates at all. And you can determine for yourself kind of how you like to approach this. But let's just kind of see what we're going to do. I'm dilating. We're going to graph this dilated image of triangle JKL using a scale factor of 2 and 0, 0 as the center of dilation. So it's really important that you identify, first of all, what your scale factor is and your center of dilation. You need to know what those are, and it's always going to be provided, unless it's a different type of problem where you're trying to solve for the scale factor, something like that. We'll see those later. So we know we're starting from the origin. In fact, I'm going to go ahead and mark that. It's the origin. It's already pretty obvious where it's at, but I put a little red dot there for myself, just as a reminder that's where I'm starting from. And so when I'm using the scale factor of 2, that means any movement that I make to get to a point, I want to double that for the dilation. So let's look at what we're going to do here. To get from the origin, let me move this out of the way. To get from the origin to point K, I'm going right 1, up 1. So I just want to double both of those. So instead of going right 1, up 1, I'm going to go right 2, up 2. And so with scale factor 2, hopefully these numbers are easy enough for everyone to double in their head. So there's K prime. I'll do J next. If I go, to get to J, I have to go right 2 and up 4. So to double that, what do I want to do? Go right how far? And then up Yeah, right 4, up 8. So right 4, up 1, 2, 3, 4, 5, 6, 7, 8. I think I put that in the right spot. And here's the nice thing about dilations. We can kind of self-check at the end. We have to be careful with that, but I'll show you what I mean. Now for L, I went right 4. It didn't go up and down at all. So just right 4, which means now to double it, I'm going to go right 8. Now, you might not find that you like doing it this way. You might find it easy enough, especially if you're good with mental math. You can just be like, oh, I'm just going to double that, double that, double that. Okay, I'm done. Okay, so I'm going to go ahead and connect these together in just a minute. Okay. So there are the points connected. So what I was saying a minute ago, when I said that this is kind of self-checking, look at your pre-image and look at your image. They should look the same, just different sizes. So if they don't look the same, that's just going to tell you you did something wrong. And you should be able to figure out which one you messed up on. Because notice that KL and K'L' look... you can kind of tell that they're going to be the same thing, just bigger. So if one of these points was off, hopefully it kind of stands out which ones are correct and which ones aren't. But anyways, you get the idea. You self-check and don't just move on if it doesn't look right. Go back and see it. Make sure you did everything correctly. All right, so now let's see what would happen if we had just done this with coordinates. And maybe after this we'll work with the coordinates more. Because in a lot of ways it's easier that way. All right, so let's look. So for J, our coordinates were 2, 4. And I'm just looking at J, not J prime. For K, my coordinates were 1, 1. And for L, my coordinates are 8, 0. Oh, I'm sorry.
8, 1.
Thank you. 4, 0. I jumped ahead. All right, now we can write down J prime, which was 4, 8. K prime was 2, 2. And L prime was 8, 0. So if those are the coordinates of the pre-image and the image, what do you notice? It's double. Yeah. And it's no accident that it's double. So what we can say here is that, how do I want to do this? So right here, we can just say, we can multiply the coordinates by the scale factor when you're dilating from the origin. All right, so that's an important condition on this. When the origin is the center of dilation. I think that's what I meant to say. All right, I got that to squeeze on there. I just abbreviated dilation to DIL. And we'll talk about this a little more. So there will be plenty of times where your origin is the center of dilation. And when you are in that situation, you can just multiply your coordinates by the scale factor. So in this case, it happened to be 2. So I'll kind of show that real quick. This happened to be multiplied by 2, by 2. If it had been a scale factor of 4, I would have multiplied these by 4. But if I tell you to dilate from a point that is not the origin, you can't do this. And so you'll need to kind of approach it in a different way. But as far as today, we're going to be dilating only from the origin. So today, it's all good. Okay, so let's look at the next one. Any questions on this? Does it seem pretty straightforward and simple? I hope it does. We're just looking at... Anyways. Now we're looking at this quadrilateral right here. And I'll let you kind of approach this however you'd like. But if you want to write down the coordinates and multiply by the scale factor, if you want to just count on the graph itself and then write down later, whatever your choice. I want you to take a few minutes to work on this one, and then we'll look at the answer. So there we are. Let's go ahead and and now you could have approached this different ways. I'm going to start by just looking at the coordinates, and you can just kind of make sure that you did it right. And again, the ultimate way of checking is just to graph that and make sure it looks like the same figure. All right, so we have a scale factor of 3, so I can take all of these right here, and I can multiply each of them by 3, and you might find that's the easiest thing to do. I know personally I find that a little easier. So that's 3, 9. What's the next one going to be? 9, 6. Next one is 6, negative 6. And the last one is negative 3, 0. Okay, now, if I was only asking for coordinates, you'd be done. Move on. But let's go ahead. And when we graph that, you probably already have that done. That's 3, 9 right here. There's 9, 2, 4, 6. All right, here's 6, 2, 4, negative 6. And then negative 3, 0. And I can connect those together. All right. So when I do that, or when you guys do that, you should see the same figure. And, yeah. All right. Any questions? Anyone have anything on that?
Could you keep it up?
Okay, I'll keep it there for a second. All right. Well, with the first two, we were only looking at scale factors of, that were whole numbers that were positive, 2 and 3. And I just wanted to show you real quick that we've got scale factors here that are fractions. And so I wanted to look, we've got 3 of them. I'll leave problem number 3 for you, but we can look at problem number 2 and 4, especially number 4. Notice that's a 1.5 scale factor. So that's kind of a weird one. It's not too bad, though, especially if you're working with coordinates. That can make your life a little easier. So if we're looking at problem number 2, we've got 3 points. You can do this just by counting from the origin. Keep in mind, notice right here that it's saying k equals. K is your scale factor. So a lot of times they'll use k to represent that. All right. All right, so if we're looking at problem number 2, if you just work with the graph, what I'm looking for on these types of problems is the actual graph of it done. So how you get there is up to you. But we could also write down our coordinates. So if I've got A, B, and C, oops. What's a coordinate for A? We're looking at problem number 2. 0, 4. B is for negative 4, and C is negative 4, negative 4. Okay, so same thing we were doing before. Is we're not reinventing the wheel here. We're just going to multiply these by our scale factor, but now we're multiplying by 1/4, which is the same as multiplying by 0.25, if you remember that. So we're going to multiply by 1/4, and I'll try and squeeze this in on the side. It's probably better I write it somewhere else. But if we multiply 0 times 1/4, what do we get? 0. Okay. But 4 times 1/4 is just going to be 1. So that's nice. Anytime that we have a 4 here multiplied by the 1/4, we're just getting 1, which makes our life a little easier. B prime is going to be at 1, negative 1, and C prime is going to be at -1, -1. All right, so we can go ahead and plot those points. All right. Again, always take the time to visually double check that your image looks like it's the same shape as your pre-image. Okay, and then I wanted to look at problem number 4, and then I'll give you guys the remainder of the class period to practice with the other two and the stuff that we have on the back. Anyways, and what we do on the back is going to be done a little differently, and I'll talk about that before we're done. But anyways, scale factor here of 1.5, if it's helpful, you can write this as a decimal. So what is 1.5 as a decimal? Yeah, there you go. So whenever you're doing your multiplying or however you approach this, if you like multiplying by 1.5, you can do that. Okay. So I'm not going to go through the whole problem, but we will look at the first one, and this 1.5 scale factor is going to be the thing that's confusing for a lot of people because it just doesn't fit into a nice neat box. So let's write down our coordinates real quick. I'll just write these down. 2, 0 for A, B is 0, -2, C is at -2, 1, and D is at 1, 2. You should be able to find coordinates. But the thing I want us to look at is we're now using a scale factor of 1.5, which doesn't change our process. It's just a weirder number to multiply by. So where is A prime going to end up? 3, 0. All right. So all we do is we take that 2 multiplied by 1.5. 2 times 1.5 is 3. 0 times 1.5 is 0. All right, so you can do this, so don't get freaked out by these really weird scale factors. Even if I gave you a really strange fraction, you could just multiply your coordinates to figure out where it's going to end up, as long as you're dilating from the origin. Okay, so you can finish that one up, and then in a minute I'll kind of debrief you on all the stuff and then talk about what the other part of this is about. So with that time that you have remaining in class, I do want you to look at problem number 1 and 3 and do those. But that shouldn't take you too long. This part right here, we're just going to, if I can get it to show up. Okay, you can skip over that unless you just want to do that. On the back side, this is a little bit different. We are dilating from this particular point in the bottom left, you can see. And you have this shark figure. Now, this is going to be kind of dilating a few points and then interpolating in between. What I mean by that is if you've got this, let's say the tip of this fin right here, down at the very bottom. All right, so if I put a point, I'll try and make it show up pretty clearly. If I put a point right there in red, and I've got my center of dilation over here, what I want to do, and you will want a straight edge for this, and I've got those available up here, especially a ruler, because what I want to do is I want to actually draw this line, have the straight edge line up with both of those, and then let's say, and you'd measure in millimeters for this, that'd be the easiest thing to do. Let's say the distance here, actually know the distance on this one. This one's about 75 millimeters. All right, let's just say it's, and you might get plus or minus a little bit from there. Let's say that's 75 millimeters from this point to that point right there that you created. You've got a scale factor of 2, so what are you going to do from there? Double it, and then where are you going to put it? Along the same line, you want to go out double the distance, 150. Okay, so now I would come over here, and I'd go about that far, and I'd put a point. And call that, I don't have to label these because we're going to have a lot of these, but you're basically going to be working with your ruler and doubling whatever millimeter distance you get along the same line. So does that process make sense? And add as many of these points as you need. So I'm going to get rid of all this real quick. So add as many of these points as you need. So if you want to add a point right here where the fin connects to the body, one right here at that fin, one on the tooth, one at different points, just put as many points as you need until you've got kind of the basic shape, and then you can connect all the points together like connect the dots. So that's what I mean by interpolate. So anyways, just work on that. It's just getting good practice with using that idea. All right, so you have some time. You can work on this and see how far you can get. We'll keep talking about this on Monday.